Welcome back. We're looking at finishing up signed integer representations. We've been doing 2's complement. This is the 4th session of lesson 2. Towards the end of the session, we'll do an exam. I'll try to put the exam information separate, so I'll try to stop streaming so that we don't have to worry about that. What was the thing that we finished with last time? So if we do this general 2's complement, representation. And why don't we actually start to extrapolate? Let's do an m plus 1 bit two's complement representation. So if I have bm, bm minus 1, all the way down to b1, b0, what did we say about the corresponding map that's given by that bit string? Negative bm times 2 to the, I think you said it, right? Was that your voice? Oh, was it your voice? 2 to the m. I scale the most significant bit by 2 to the m with a negative, and then all the prior bits are just the way they were before, right? Okay. Now, I would like lower and upper bound. So if I say y in z, then the range of y's I can store in m plus 1 bits is, and let's do it in decimal, and we'll do it in binary. We won't do it in hex. Why won't I do it in hex? For a direct translation from binary to hex, how many groups of binary digits do I need? Groups of size 4, but in this condition, m can be anything greater than 1, right? Greater than or equal to 1. Okay. So what's the lowest value I can store in this particular representation? Negative 2 to the m, less than or equal to y. What's the highest value I can store? To the m minus 1. What's the corresponding bit string that stores negative 2 to the m? Total of how many bits? So that's a single 1 followed by m zeros. That's the lower bound. What's the upper bound? A single 0 followed by m1s. What's the conjecture that we made? We made a very, very specific conjecture on the last one. So this means if less than or equal to y less than or equal to 2 to the m minus 1, with y a non-negative integer, then to encode negative y, we use what? What's the formula we use to turn a positive number into its negative self? Okay? This is not a proven fact unless we actually show it, right? Okay, so let's go ahead and do that. Let's show that the work that we're doing is not some random bit of knowledge, but in fact that we can establish this idea for ourselves. Okay. So let's think about this. If we let y be a non-negative integer with 0 less than or equal to y less than or equal to 2 to the m minus 1, that would immediately imply that we could write y how? As a string of m plus 1 bits. And what do we know for sure? What must be true if this is a positive number? All right. So in that situation, we would have y equal to the sum of, I guess we should be a little careful here, right? Let me make sure that I'm not smoking anything here. Oh yeah, there it is, there it is. So this would be negative b to the m times 2 to the m plus the sum from I goes from 0 to m minus 1 of b to the I times 2 to the I, except the fact that we've assumed, the fact that we've said that this leading bit is 0 means that indeed this encoding is identical to what? The unsigned representation, right? It's just that the one in front of it goes away. So now we think to ourselves, so let's go ahead and remind ourselves, what is the bitwise complement? So we say to ourselves, we're making a claim here that negative y was going to be the bitwise complement of this thing plus 1, where the bitwise complement, so here's b to the m minus 1, all the way down to b1, b0, we're going to take the complement of that. So this is what we call the complement of y. And actually, the bitwise complement, we actually take the inverse or the opposite of each individual one, right? And we say b sub I bar, when is b sub I bar equal to 0? When is b sub I bar equal to 1?
B sub I is 0, b sub I is 1, and then vice versa.
Okay. So if we look at negative y, the claim is that this thing is going to be this thing plus 1. Okay, well, what do I mean by 1? What is 1 in this system? The number 1 would be an m plus 1 bit. How many zeros lead that thing? M of them. And then this is a single 1. The total one of these things is an m plus 1 bit. This thing here would literally be b sub m minus 1 all the way down to b1, b0. Okay. So now the question is, well, what's the relationship between this value that we have here and the corresponding value of x? So note, or y, I'm sorry. What would you know about y plus negative y? What value should that be? If I add two numbers together, what should I definitely get? 0. Okay. Well, let's see. We've made this conjecture that negative y is written like this, and then y is the opposite. Let's go ahead and look at this. So this would be b sub m minus 1, dot, 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 b1, b0. Let's go ahead and add bm complement, bm minus 1 complement, b1 complement, b0, and then we're going to add 1 to that, right? We're not sure what that is yet. What was the claim of this representation? Okay, so this is where I would go back to Adam. So what is b sub m? It's negative b sub m times 2 to the m. What about these ones? Sum from I goes from 0 to m minus 1 of b sub I times 2 to the... Making sure I'm awake. What about this one? Yeah, it's just whatever this bit was, it's the opposite, right? Times 2 to the m plus the sum from I goes from 0 to m minus 1 of, and then I should get mad at myself because up front I'm still adding 1, right? Anybody see a very, very natural way to group these things? Which ones are kind of grouped together? Those two kind of group together. And then for each value of I, what do you notice? You have scalars on the same power of I, right? So let's go ahead and look at this. This is negative b sub m times 2 to the m plus negative b sub m bar times 2 to the m plus, what do I know about a finite sum? Each of these things is just 0 or 1. What do I know about a finite sum? If I have a sum with the same indices, what can I do? Okay. Anybody see some algebra that you can do there? It's called reverse distributivity in a Math 105 class, right? Some people call that factor. What could you factor out of those first two terms? How about the next two terms, or the next set of terms? Okay. What do I know about b sub I plus b sub I bar for all I? That must be 1, right? Why is it 1? Because whatever, if one of them is 0, the other one must be 1. I guess I should get a new color here. What did we just claim? Everywhere where I see a bit added with its complement, that sum turns into the number 1. So this thing is now 1, right? These, every single one of them becomes 1. What is this? What do we know when we sum? So another way to write this is 2 to the 0 plus 2 to the 1 plus 2 squared plus 2 to the third all the way to 2 to the m minus 1. Yeah, this thing right here becomes 2 to the m minus 1, right? When I sum powers of 2, I mean, we've talked about this before. I don't know that we've ever proven this. That would be a fun activity for you all to do. So let's just go ahead and take powers of m. I suppose I should start with 0. Okay, 2 to the 0 is what? 1. Shit. So formally speaking, I should do m minus 1, I think. Okay, so tell me this. If m is 1, what is m minus 1? 0. Okay, let's take the sum from I goes from 0 to 0 of 2 to the I. What's that? That's 2 to the 0, which is 1, which is indeed 2 to the 1 minus 1, right? Okay, let's take the next one. When m is 2, what is m minus 1? 1. This is now the sum from I goes from 0 to 1 of 2 to the I, which is 2 to the 0 plus 2 to the 1. What is 2 to the 0 plus 2 to the 1? 3. What is 3? Okay, let's try another one. If m is 3, what is m minus 1? 2. That means the sum from I goes from 0 to 2 of 2 to the I, that's 2 to the 0 plus 2 to the 1 plus 2 squared. That's another way to say that is 1 plus 2 plus 4. What is 1 plus 2 plus 4? 7. What is 7? Well, it's 8 minus 1. That must be 2 to the 3 minus 1. This is now a proof by induction. Sadly, you all don't have Math 22 as a prerequisite for this class, because that would just be too easy, right? What's this? This is 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3. That's 1 plus 2 plus 4 plus 8. What's 1 plus 2 plus 4 plus 8? 15. What's 15? Okay, so what's the general hypothesis? if I sum the powers of 2, starting at 0 going to m minus 1, what's that sum equal to? Whatever number I stop at, the sum is 2 to the next number minus 1, right? Okay, so that means this entire sum becomes 2 to the next number. What's the integer immediately after m minus 1? M. What's that number? 0. Which means y bar plus y plus 1 is 0, which means this number right here is the negative of that number. Now this is a theoretic, or excuse me, a formal mathematical argument that says that when we do 2's complement, we can literally just invert every bit and add 1. Let's go a little deeper and then we'll do some testing. So, let's do integer manipulation with 2's complement. And if you were thinking, hey, I thought this was a Matlab class, I didn't know I needed to know math, what I'm going to say is that's very, very valid intuition. The problem, though, is that when we start to do manipulations later, if we don't understand the concepts underneath, like, let me say this so you understand where I'm going with this. Let's make something a little bit more interesting. We've seen this before, we're going to do it again. Would you agree that those two numbers are not equal? Okay. Would you agree that this is a ridiculously simple line of code? I don't. But you're meant to think that, right? Because the subtraction is subtraction, no? Let me say it this way. When did you learn about what subtraction was? So you're supposed to be subtraction specialist, right? You, at this point in your life, you should be masters of subtraction, true? Okay. If I think about this line of code and I am not aware of these mathematical ideas underneath, the stuff that we're studying theoretically and how it's implemented, what should this output? Should output 1. What's it going to output? What are they? Oh, I guess I copied and pasted. Why could you say that it outputs 0? My young child, as he learns math, he'll say, no, that should be 1. But why were you able to say that it outputs 0? Because you recognize that the practical implementation of that math depends on the data structure that's used. And you're able to predict the error based on your strategic understanding of how Matlab functions. Now, I'm going to be honest with you, unsigned and signed integers are child's play. This is not how doubles and singles work. They're child's play. But how did we become adults? We played for about 18 years, right? When we get to a place where we're going to study the IEEE format, we're going to be using a map that is the pinnacle of scientific discovery from the 1950s to the 1980s in terms of how to encode integers. I will expect that every single one of you can encapsulate that idea for yourself so that you know how Matlab and indeed how all scientific computation encodes integers. 20 years from now, that will be one of about 4 capstone results in my class, but I haven't had the chance to develop my class. What we're doing right now is setting the theoretic understanding. We're setting a foundation in your brain so that you can really understand what's happening when you encode numbers in Matlab, so that you can start to predict the type of errors that you will code up as a function of doing digital computation. I could skip all of this. I could not go into any of this and teach you syntax. But here's the claim. If you tried to learn this for yourself, my bet is you would need about 7 years. Do you think you need 7 years to learn syntax? Here's another question. If you wanted to learn syntax, what would you do? Go look it up. If you wanted to learn this, what would you do? En el nombre de Padre, de Hijo, de Espíritu Santo, I might encourage you to go to your local church and pray. This is not easy stuff to understand. So I am choosing, I want you to know this, I am choosing and I'm making a decision as your instructor to try to give you deep understanding of what's happening under the syntax numerically. If the heart of scientific computation is encoding numbers in computers, then I want you to have a very, very well-refined, mature understanding of what's happening with those numbers. And I want that to be based in as deep of knowledge as I can give you. I claim that that is actually teaching you a lot more about coding than teaching you syntax. I have people argue with me about that, but this isn't their course. This is my course. Right? Stick with me. I promise you, as the quarter goes on, you're going to see some stuff that is quite unique. So, let's go back to this. Imagine that I wanted to, and then we'll go to the test, and then we'll talk about lab. In lab, I have one thing to share with you. What is negative 45 plus 25? Yeah, I think somebody said negative 20. Okay, so let's do some, we'll call this decimal. Okay. Let's go ahead and code each of these things in 2's complement. So what is positive 25 in 2's complement? Looks like 16 plus 8 plus 1. So I suppose that's going to be 1, no 2's, no 4's, 1 8. 116, no 32's, no 64's, no 128's. Okay, let's try 45. What's 45? 32 plus 8 plus 4 plus 1. Okay, so let's think about that for a minute. Let's go from the least significant bit up. 1 1, 0 2's, 1 4, 1 8, 0 16's, 1 32's, 0 64, 0. Okay, what does that immediately mean about negative 45? 1 1, 0 1, 0 0, 1 0 plus, that one's not too bad, right? So what would that be? Okay, let's write that in hex. What's the hex representation there? I believe we called that D, right? Because D is 2 less than F?
E, F, C,
It must be D, right?
D3,
D3?
D3.
D3PO? No.
No, you should use C. You should like figure
And then what about this one? Okay, let's go ahead and check. Let's always check our work. It's the benefit of a calculator that it helps us check our work. So let's go ahead and do int 8 of 25. Sorry. 19, right? Int 8 of negative 45. Okay, so check this out. Just go ahead and pretend that those are now unsigned integers and you just do a binary addition on them. What do we do in binary addition? 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1, 1. Claim. We have now mapped in 2's complement, we have mapped the problem of subtraction to the problem of unsigned binary addition through the representation of our number. Don't trust me. Let's go ahead and write this in hex. It's got to be E, right? Eight plus 4 is 12. Which means that through the encoding of our data, we can solve all addition and subtraction of signed integers using the exact same circuitry that we designed for the addition of unsigned integers, with a caveat.
Why you want to check it through hex? Like it's faster to do it by unsigned and signed.
I'm not.
Like why we like, to double check we transform it to hex?
Yeah. So I mean, what we don't really care about hex, right? What we care about is the actual value of this thing. But the point of the matter is, are you starting to recognize the following statement? When we do computation on a computer, not all the computation that we do is going to be accurate. Another way to say that is, depending on the type of data that we encode, the limitations of my data class cause errors that produce inaccurate results. So as a coder, if I'm gonna understand the errors, one of the things that I have to know is, well, what data class am I using? What type of encoding does that lead to? What type of errors does that lead to, depending on the corresponding operation that I'm doing, right? What I'm teaching us to do in this situation is to accurately predict the behavior of Matlab's internal representation, not by looking at the interpreted value. The interpreted value Matlab coders do for us. What I'm teaching us to do, the nice thing is Matlab gives us what you might call insight into the voltage value stored in memory through hexadecimal. So what I'm teaching you to do in this situation is accurately predict what type of manipulation is going to happen in the bit string in memory, and then confirm your predictions not through the value that you have, but by looking at the actual bit string through the hexadecimal representation. This sets a foundation for many data types, and I think that as young programmers, when I look at myself, my job is to teach you, right? I want to give you the absolute best experience that I can give you. Personally, I don't think syntax is the best experience that I can give you. I would much rather have you actually really understand at a deep level what's happening underneath, so that when you go to implement syntax, you can interpret what the syntax is doing and predict errors, and when it comes time to debug your program, you can have insights into the type of errors that you might expect given the type of syntax that you're using. So why am I, now I ask you that same question back, why am I teaching you to look at hex? What does the hex give you an understanding of?
So what happens if we take this error?
Yeah, the hex is a representation of the actual voltage values in memory, right? And then Matlab is interpreting those voltage values to produce a string that represents the corresponding value in the command prompt. But the number -20 is only through a mapping that Matlab is actually placing on this bit string in memory, right? If I change the mapping, what happens? If I change the mapping of the bit string, what would happen to the corresponding number that I expect? It's a different number, right? So the interpreted value of the bit string is really what the bit string, the string of bits is just a string of bits. It's a set of ones and zeros. It's the interpreted value that gives us the corresponding numerical representation of that bit string through our chosen programming language. So I'll stop here. I think this is a pretty good place to stop. I do want to call out attention to something that's in your notes, and then I'll answer questions about the test. I have one kind of a fun thing that we're going to do at the start of lab today, and then I'm going to let you keep working on lab. So do you remember we talked about this idea of 2's complement? This is a review of what we've done. For an 8-bit 2's complement, the lowest is -2 to the 7th, the highest is 2 to the 7 minus 1. In 2's complement, what do we know about zeros? How many different zeros do we have? A unique zero representation. When I take the bitwise to negate a number, what do? Take the bitwise complement and add 1. We didn't really talk about the overflow rule. There is an overflow rule. I go over it with in your notes. I'm definitely not going to test you on this because I didn't talk about it out loud. If I wanted to subtract two numbers in 2's complements, how did we do that? To subtract A from B, so B minus A, take the 2's complement of A and then add it in unsigned integer format to B, right? And then range expansion, we talked about the idea if the integer that you are trying to encode is outside this range, then you would extend your range to make sure that you're capturing that data. Let's go ahead and answer your questions about the test. I actually will make a copy of this for you right now. One of the things that I really believe as a teacher is that this is not my class and you don't serve me. This is your class and I serve you. Now, what this means in terms of your test is I have this thing that I'll make a copy of. I meant to do this morning, but it didn't happen. I like my students to write their tests. I can straight tell you, if you give me a question that says, "Please, Jeff, please ask me what 1 plus 1 is," I'd really like that. I probably won't write that on the test. The goal of this is not, let me make this test as easy as possible. So I reserve the right to choose my own questions. However, if you write questions that you're genuinely interested in and that test you on the material that we've covered this far, and you can explain why you're interested in that, and I can see, oh, this is actually getting pretty deep, I'll choose those. Let me show you some examples of what this looks like. Do you know why This exam, I don't know if you've clicked on this, the sample one. Oh, sorry. Oh, you were looking at this. So I will make a copy of this right now. I'm going to go over to the other room and do this for you. So right here, there's going to be this write your own exam problem. That assignment will be due next time we see each other. How many problems do I expect? How would you know that I expect 2 problems?
It's a bowl. Almost reading that.
Yeah. So you're going to write in this assignment, you're going to write 2 problems that you believe are most valuable for you. You can choose them from anywhere in the notes. You can choose them from the examples. You can choose them from the exercises. You can choose them from anywhere you want them. You can make them up. For each problem that you're going to do, write a full statement. And then the most important thing for me is not only the statement, but more importantly, why do you like this problem? What about this problem makes you smile, and why do you think it's valuable for your future? Check this out. This sample exam, so if you go here, do you see there's a sample exam 1? Has anybody clicked on this stuff yet? Full solutions? Last quarter, my students said, you should post a sample exam. And then I was like, you're right. And then they're like, you should post full solutions. And then I was like, you're right. Do you know why this is called a sample exam? Because I give it to you. Guess in winter 2019 what this was called. Exam 1. This was the actual exam. Guess who wrote these questions? Yep. Now, let me be quite clear. If Ethan says to me, like, let's pretend Ethan gave me this exact question. I don't know how, he could do that actually. So he's like, hey Jeff, I really want you to test me on this question right here. What's the likeliness that I literally just copy and paste Ethan's exact question onto the test? Exactly 0%. There's no chance in hell that I'm going to take the exact question that you wrote and put it on my test, right? In other words, I'm going to edit the question, look at what it is that you're asking me to test you on, and then write a question that is representative of this knowledge. With that said, every single question on this test was written by a student with my editing. The ones that made me laugh the most are students that wrote a question and then got their question wrong. That happened like 5 times last quarter. like for example, I had a student that wrote this question. This was, I can tell you the name of this student. He's now at UCLA. And he got it wrong. I was like, oh my God. So know that when you submit your 2 questions, if they're good questions and you have good reasons, I'm very, very likely to choose some of your questions. Which means you might want to know the answer to your questions before you submit them. But you all don't know, some of you don't know me, right? Do you know that in this class there's something called test corrections? So there are 2 drafts of every test. There's the first draft that you take. I grade it, I give it back to you. Then there's a second draft. Your final grade is the grade that you get on the second draft. I am a little bit nebulous. I'm still getting through this. Do the best you can on your first draft. So test corrections are not about the following algorithm. Let me bomb the first draft because I have other stuff going on in my life. And then he'll just give me points back on the second draft, and that's how I pass the class. That's not how this works. Because that's really taking advantage of me, right? Like if you're not ready for the first draft, just look me in my eyes and be like, I'm not ready for this, can I reschedule it? And then I'll give you an answer for that, right? But for the most part, do the absolute best that you can on the first draft, but don't trip. If you make honest mistakes and for whatever reason you weren't ready, don't trip. You'll have a chance to look back over it. And we'll talk about that when we come together. So these are representative questions that were written by my students. You have access to full solutions because my students told me last quarter you should post full solutions. I had another student say, hey Jeff, if you're going to test us on syntax, you should allow us to use Matlab, and I'm kind of down for that, to be honest with you. Which means that I'm probably not going to test you on syntax this quarter because I can't be sitting next to each of you, and some of these questions you could find easily the answer online. I want you to use your brain, not Google query.
It's really basic. How does food work? You give us example food. saying, how would this turn out if you left?
I won't be testing you on loops because I haven't formally covered that, so to speak, right?
So we have more like mass.
Well, say it again.
So we have more mass questions than syntax problems.
I mean, I'm open. I'm not. I think it's kind of nice to give you some syntax, especially because we've studied this before. So I actually kind of disagreed. I agreed and I kind of disagreed, right? So like you all spent, how many hours of class time did we spend on linspace and the colon operator and all this stuff? Like 2 full hours, right? And then I have like an 8-page question sheet that I produced for that. So like my feeling is that's fair, right? But that guy was like, hey Jeff, your whole point in this class is not to worry about syntax, that's look-upable. Why are you testing me on syntax? And I was like, oh, that's a fair criticism, right? This is not the last day we're talking about this. On Monday when we see each other, we can renegotiate the bounds of this, right? Because I'm going to be collecting your problems. But I did want to show you some of the types of problems that we do this. Some people ask me, hey Jeff, is the write your own exam problem assignment graded? Depends on what you mean by graded. Like, do I assign a letter grade, store it in my grade book and give it back to you? No. But I use your work to write the test. If only 3 people submit them, I will be doing problems, right? But most students, I mean, how many of you have ever written your own test problems? How many of you kind of like that idea that you could write your own problems and have them on the test? So then that's the grade. The grade is that you have control, assuming that you take it seriously, right? Assuming that you're actually thinking like, what is it about this class that I value? So I will make a copy of that write your own exam problem assignment and I'll bring it back before the lab that this ends. Any questions for me? Here's a question for you. What's fair? What content would be fair?
So, I think we covered it in the notes. So rewatch the videos. If you have a question on one of the videos, write it down, study it, and submit it for
Up through today, what have we covered? Lesson 1, lesson 2, lesson 3, lesson 4. Lesson 1 was broken into 3 parts about Matlab stuff, basically, right? So if I were to ask you to respond to questions on an exam, from what material might we choose? Lessons 1 through 4. I don't like the idea that unless on Monday of next week we're going to do lesson 5, right? I hate the idea that we would do it on Monday and then you'd be tested on it on Wednesday, because then you only have 2 days to think about it, right? So if it's okay with you, I would like to exclude lesson 5 from exam 1. Is that okay with you? Submit that. I really do hope that every single one of you takes the chance to really think about what questions you want to be tested on, why you care about that, how that relates to your future, and then some creative things that you want to see. I've had some students actually write questions that are like 12-hour questions. And they're like, I know you're in the assignment, they'll be like, I know you're not going to test this because this is really hard, but I wanted to capture this because I actually care about it. That's cool. Other questions or concerns? Yep.
So you said you're probably not going to test on Matlab syntax, right?
Can we negotiate that on Monday? So I write the test questions that you feel you want. I am open to testing on Matlab syntax. There's a part of me that thinks there are some syntax pieces that we've talked about that you should probably know about, right? If you feel the same way, write the questions. We as a group can converge on what we feel is fair the next time we see each other. You can make an argument and I'll listen to that argument and then I'll plan accordingly.
You just try to think about if there's any place we could go. I guess then we could watch through all the videos, see all the functions that we use to just check if there's a nice place that.
That's a good suggestion. When I shut up, will you come up and I'll write down that suggestion and see if I can make a list of that?
I don't know whether or not we're allowed to use Matlab.
It wouldn't be nice to use Matlab on a test. What's the immediate course integrity problem that comes up there? You have a computer open that has access to the internet.
Which you can ask a fellow student.
Yeah, which means that literally,
You can ask.
and I'm not against, to be honest with you, like I'm not against the idea of group tests, but this incentive structure is such that some of my students think that the point of the class is the grade, which is important, right? Like grades are important for sure. And so they'll have like a really, really strong student in their group and they'll let the strong student solve everything and then they'll just write what the strong student says down, and it doesn't actually represent what they understand, it represents what the strong student understand, and they copied, and I can't tell the difference, right?
One solution to that, which you don't want to implement because it's proctoria monitors the writing process. It's online.
So for future classes, I don't know, can I turn that around in 7 days?
I've never used it, but I'm about to.
Okay, so then, so you have one suggestion for me that I need to be aware of. You have another suggestion for me. Let's say this. I am open to the possibility, but you heard my concern, right? If I can't, between now and next Wednesday, find a way to address that concern, then the answer is no. For you all, you're going to be planning over the weekend. You might plan as if the answer is no. And if the answer becomes yes, then that might be a very pleasant surprise, right? Does that answer that question? And then will you visit me at some point today so that I can write down what you've said and do some research on it? I'm not going to promise that I'm going to be able to do that by next Wednesday. I am going to promise that I'm going to write it down in the appropriate space in my life, wherever that space is, and then look into it and get back to you, right? Other questions? Can we put this on pause? Instead of, so go ahead and scroll down. We're on Engineering 11 website. Every one of you, I want you to do this with me, okay? Go ahead and scroll down to Lab 3. And then do you notice the Engineering 11 Matlab templates? Click on that sucker, and I would, Derek, do you have a computer with Matlab on it?
Yes.
Do this.
Oh, no.
Oh, okay, that's all right. Well, this is going to be online, so this is kind of nice. So I'm hoping that all of you are in Matlab right now. And then you're going to scroll down to Lab 3 and click on Engineering 11 Matlab templates. And then find the folder in which that lies. So mine's in the download folder. You all are going to do great on this test, by the way. You're going to rock this. You're so smart and hardworking. You're amazing. When I grow up, I want to be like you. I just have to grow up first, right? My students are my huge part of my inspiration. All right, so let's go to MATLAB real quick. I want you to go to the command window, and I want you to type the following command, user path. So type the command user path. Okay. Once you have that command, I want you to open a new file in your operating system so that you can see both the thing that you just downloaded and the user path. So for me, it's like, let's see, C users, PSME students. I am a student too, isn't that fun? Documents and MATLAB. So let's see. Where do I go? Home? How do I get to that path? Documents, MATLAB, right? Okay, so the thing I'm going to say is, when I type a command in MATLAB, MATLAB checks this path first. So I have given you access to, so like if I use the word new function, that's a command that we're generating today. What is MATLAB complaining about right now? It's telling me, hey, whatever this new thing is, I can't find it. because it's not in my search path. So what we're going to do is, when you've downloaded this file, so on my website was the following file, right? I don't know where the website went. Right here. That file has four subfiles in it. Stop. And then you're going to copy and paste each of those four things, copy into the user path, into the what you might call the mommy of all files for Matlab. So now Matlab knows, hey, if you use the word new, this is the script that I expect you to do. This was written, I got this off the online community. So we can actually check the person that did this. What's their name? See if you can find the person who wrote this script. Yep. This was on the online community, right? Guess what this script does. See if you can tell what this script does. So right now, has anybody recognized that if I go up to Matlab
It's outlines
and I do this, I have to do all of my typing and documenting and all the stuff by hand? And my teacher is a freaking punk and he makes me do all this stuff and it takes so much time. That's kind of frustrating, isn't it? Wouldn't it be nice to just have a template for all script, function, and class files that has everything predefined so that all I have to do is open it and then I can just delete and put in? Okay. And then I could call that template from a function or even a button, right? So check this out. This morning, this is a 90-minute project. Guess what default script is? Shut up. Will you just do what I tell you? Yeah.
It's not a MATLAB code.
Yeah, so check this out. So let's go to new. This is not the same as, let's see. I'm trying to create a shortcut. Do you see a way to create a shortcut? You'll see, we're going to do this together. I want to have a button where I can click the button and my script automatically pops up. App designer? Nah, I don't want an app designer. Could someone figure out how to create a new shortcut? I did it in Mac this morning, and this is not a Mac.
You just move the file over while holding your right mouse button. That's your question.
You see it? This is where it was in mine. I hit the little new and then it was like shortcut. So here's the question that I have for you. Does anybody else see the new shortcut thing that has a Mac?
No, it's not. Maybe it was an older version or something.
Oh, it could have been an old version. Okay, so here's the question I want us to solve right now. Please find a way to do new shortcut.
Would it not also work to just add the path?
I knew I should have done this at home. But this is good for you all, actually.
New? Is it under new? No?
It's under new for you, huh?
Yeah.
Yeah. You have a Mac? Yeah. I'm trying to create a button that's under. I mean, can I? Do you have yours? Can you bring it up? I'd like. We can show what we can do on the Mac, and then, of course, Windows is just not as fun as a Mac.
I was looking at the documentation. It just says, about
Oh, that's okay. Watch this. Watch this, watch this, watch this, watch this.
Yeah. So he actually tells you exactly how to do this. Click on the Home tab and click New.
new.
In the shortcut.
It should have command shortcut.
Yeah, command shortcut. So this is so he wrote this, and then select the command short. Do you see that in yours? So this must be written in 2016. I did it in 2016. There was no problem whatsoever.
I have,
That's okay.
What if you just do it in
you have iOS code there.
Say it again.
What if you just do it in add shortcut project name?
Where does it say add shortcut?
If you go to documentation.
Oh, it's a function? Okay, so what's the function? Add shortcut?
Uppercase. Lowercases or uppercase s.
Oh, I see it now.
You see it?
Yeah.
Can you bring yours up?
Case s.
Yeah, it's because I was in the script on the main.
So let me show you how easy this should be. Okay.
That script works really well.
It's cool. It's a nice one.
My computer does. Sometimes if you're trying to do something on the computer when you plug it in, it'll kind of bug out, and so if you just wait for it to.
Oh, okay.
Yeah, it's sometimes weird with that port. Okay. Give her some time.
So I'll show as soon as we get to this thing, I'll show you how to do
Even
this.
on when you're on your main, it doesn't. Like when you're on the script, it only gives you a few options, but when you're on the main home.
Well, this takes. What did you search, Michelle?
In the documentation.
Doc shortcut.
Sh-
Just add shortcut.
You just wrote shortcut.
I wrote create shortcut.
Keyboard shortcut.
If you do shortcut, it just
Matlab.
should be the first option. Just shortcut.
When you search up the shortcut, add
Yes, it works for me.
shortcut. What's a function? Add shortcut. It's not a keyboard.
Does it have it?
It's like lowercase a, b, b, uppercase s, and lowercase s.
And then actually, when you do that, it actually creates a button on your. What does that function do?
Adds a shortcut to the file.
Does it allow you to have a button up here where you can click? Sorry, where you can click that button and have the thing show up?
You could try to see if settings has a specific.
It's not a new function. The ultimate goal is to be able to click a button and have a script that has all the documentation already the template for the documentation done, so that all you have to do is just replace that documentation.
Just using that.
Just using the button. So like this button's right here, right? So like I figured this out for Mac. I don't know what the hell's going on with PC. Yeah.
It's supposed to be just like this, right? Is this where you're supposed to do the new functions? Like, just do this, and you're supposed to do that?
Yeah, except I want the function to be I spent like probably 70 minutes writing a very, very nice summary of, yeah, and I'm giving those to you, right? So like these, I wish I could open these. I'm just like, these things right here have some very nice formatting for writing good code. So like I spent literally about 70 minutes today putting together a nice template for a script.
Would it be possible to just alternatively make save this folder or path and then just call it?
Yeah, for sure. But you would imagine I should be able to add new buttons, right? If they can add buttons, I should be able to add buttons. You found it?
It's called favorites now.
Okay, where did you go? Customize toolbar, maybe? Where'd you go?
It's called
Favorites.
Where's favorites?
Right there. Just go right.
right there? Oh, okay, favorites. Okay, now what? New favorite? Ah, you son of a... Okay, so we're going to do that. So thank you so much. Wait. Yay! What are you learning about doing stuff? Takes time, right? Yeah, I'm so happy. This is really fun. I'm having fun. And I can tell the looks on your faces, you're having fun too. That's awesome. So we're going to write the words new script. And then here we're going to do new script. So let me show you what you're doing there. This function new, so the code that's going to execute when we do new script is this function new. And it's written by this guy, whatever his name was. Do you remember his name? Benjamin Pilat, right? In that function, he has a case, like he has different cases. One of them is called script, one of them is called function, one of them is called class. So, and then what we're going to do, this is kind of fun. I know, it's all fun. I know, stop. Maybe case, lowercase s for script, I don't know. Add to quick access toolbar. The quick access toolbar is the thing up top here. So if I click this, this is going to show up. I'm not going to do that. I did that this morning. I didn't like it. So you see this new script? Check this out. Now when I hit new script, I stole it from other people. This is why it took 70 minutes. So if I hit this new script, you all said you all are doing some of your reading, right? And it says like writing good code matters, no? So when I hit the regular new script, I have to redocument everything for myself, right? But now if I go to mine, it's not mine, it's ours, and I hit new script, I mean, one of the things I'd like to do is have this in the actual like button, but if I hit this thing, check out what happens. What script file do I have? Like I have everything ready. So like what do I have to do as the author of the script file? I got to give it a name. And then I also have to give it a one-line description. And then I have some additional information. And then I have information about the output. And then I have examples of the code that I write. And then I have other required files. And I have other Matlab files. And then I can see other functions that are related to this.
You can add a button.
Oh, okay. So, yay! This is so cool. Teach me. Okay.
The first button on the right is
No.
hover over the command.
Hover over the command.
So go to the favorite.
Okay.
Get out of the editing tab.
Maybe I just dock this sucker, huh? Okay, so you're telling me to go home.
Favorite. Hover over the command. Go to the right. Right. Yeah,
Oh, cool. Okay, let's do another one. So let's do new. I'm out here trying to function. Could you guess what line of code we're going to execute? And then maybe we do lowercase. I mean, you could do whatever the hell you want to do. And then in that case, why don't I just add it to the quick access toolbar immediately? Oh, no. Let's go ahead and edit this command. No, I don't want to show the label, right? See that? Look at how beautiful that is.
So it matches your style with your requirements.
Yeah. It's not, well, yeah, I mean, I'm requiring it, but forget about me, right? Like, this class is going to be over in 12 weeks, so as soon as it's over with, like, you could do whatever the hell you want, right? But, like, if you're doing that reading and you're thinking deeply about it, what are you noticing? I don't know if you've done it yet. Has anybody done any of the reading yet? Have you got to the last 5-pager, the 7-pager that's really hard to read and dense?
Yeah.
And then the 3-pager? What are you noticing about shitty code?
Bad
It's just documentation. It's just.
Part of writing good code is writing good documentation. Part of writing good documentation is following a template that's easy for people to file. If you use the new button on Matlab the whole time, every time you write a new script file, you got to redo the documentation. But now we are creating our own, we're optimizing our Matlabs to have these things. The last thing I'll do, let's go back to favorites, and then I'll shut up. I promised I was going to shut up. It just took me a little longer, right? So the last thing I might encourage us to do, and we're probably not going to get to this quarter, but it's there. So I'm going to add a new favorite, and then I'm going to call this a new class. Could you guess what line of code I'm going to do? New class. We're going to add this thing. Let's do lowercase c. So now, if I want to create a class file, boom. Done. Isn't that cool? Did you just say it was so cool? Oh yeah. So anyways, the point is that was 90 minutes of work this morning, and it's now another 30 minutes of work here. But we did it without. So Michelle, thank you for teaching me. Nick, thank you for teaching me. Okay. So keep working on Lab 3. This is online in case you need it. Mac is done differently, but the directions for Mac are in here. And I will see you again on someday.